never are. Or the homeless. It is. You are not writing code for a machine anymore. You are stepping into a conversation with a highly intelligent system that reacts to your exact phrasing. Think of this as instructional design for artificial intelligence. You get better results with sharper directions. Large language models like GPT-4, Claude, and Gemini train on massive text archives. They do not hold human knowledge. They simply predict the most likely next words based on past data. Prompt engineering shapes those predictions by providing structure, context constraints, and examples. A well-engineered prompt steers the model's probability distribution toward your exact target. You get a structured JSON response, or a creative story, or a technical breakdown. Has I-don't-ly meeting to sound. No-go can be funny. Way mean. The model hands you a generic Wikipedia overview that covers nothing deeply and surprises absolutely no one. Try a sharper prompt instead. Explain transformer architecture to a software engineer who knows Python but not neural networks, and use an analogy they will genuinely appreciate. Now you receive a tightly tailored response aimed at a specific audience. That creative constraint naturally sparks a memorable explanation. You are a technical educator. Write a 300-word explanation of how attention mechanisms work in transformers for a senior developer. Structure it exactly like this. Open with a one-sentence summary that serves as your elevator pitch. Follow it with the core intuition backed by a real-world analogy and a tiny Python-style pseudocode example that maps directly to code. This changes everything because a single shift creates a direct ripple effect you can measure. We keep the delivery conversational and strip out every ounce of fluff. If a technical term slips in, we define it instantly. That final step consistently delivers a polished, structured response you can actually put to work. You stop guessing and start executing. These represent two completely separate ways to customize artificial intelligence, yet people constantly confuse them. We clear that up right now. Prompt engineering works directly with the base model exactly as it sits. You steer the output through targeted prompts and clear instructions, while keeping the whole process fast, inexpensive, and fully reversible. Need a different style? Skip the heavy lifting and just tweak the prompt. Fine-tuning trains the model on your own data to rewrite its actual weights. You are essentially teaching a brand new skill at the foundation level. It burns cache and takes forever. Those changes are irreversible since the model becomes permanently specialized. So which path do you take? Choose fine-tuning when you need consistent formatting or style across many tasks. Stick with prompt engineering for one-off custom behavior or quick experiments. The real sweet spot is using both together. You fine-tune models for foundational knowledge like your industry, then layer prompt engineering on top for exact tasks. Vibe coding is the newer cousin, and it is exactly where things get interesting. Vibe coding means handing your project to AI assistants like Cursor Replit Agent or Claude Code, and writing code through plain conversation. You give minimal explicit instructions and let the system handle the heavy lifting. You describe what you want in broad strokes, and the AI figures out every implementation detail. Traditional prompt engineering takes a completely different approach. You craft every single word deliberately to force a specific result. Vibe coding is all about exploration, so you describe what you want, watch what happens, and tweak it from there. It is less about crafting one perfect prompt and more about steering a steady conversation with your AI pair programmer. Vibe coding trades precision for speed. It shines when you need to prototype fast, break through a roadblock, or whip up a quick script. But production-grade code demands something sturdier. You will want prompt engineering discipline with clear instructions, strict constraints, and thorough verification. You do not need a fancy degree to get started. You just need genuine curiosity and a real willingness to keep iterating. Start with the basics by understanding prompts, context windows, temperature, and few shot examples. Those core concepts are your starting point and everything you need to begin. Run the exact same prompt through ChatGPT, Claude, or Gemini every single day. Tweak tweak the structure each time. Watch how the output shifts. You need scaffolding when the task gets complex. Try Clear to anchor your context, list explicit, adaptive, and refined steps. Or use Crete to map your claim, reason, example, apply, transform, and evaluate. Models will always hit edge cases. Learn to spot when they hallucinate, drift from instructions, or drown in context overload. Fix those cracks before they break your workflow. Stop guessing and start reading real examples. Dive into our per OpenAI Hacker News and the Springboard sources below. You will instantly pick up community-tested prompts and hidden techniques. The fastest way to learn is to actually build something real. Grab a newsletter, a script, or a dashboard. Write the prompts that bring it to life. Your skill compounds fast. After a few weeks of deliberate practice, you will glance at a mediocre AI response and instantly know what to tweak in your prompt to hit excellent. If that made it click, subscribe. We break down the frontier of tech and AI every day.